Alright, finally, Exponents Day 3, or Day 5. We have to go all the way back into the middle of last semester to remember how this all works. One thing we're going to bring back in is our conjugates, and the other thing we have to remember is that when adding and subtracting your radicals, you may only add and subtract radicals of like terms, and the way they have like terms is if the radicand is the same number each time. That's the number underneath. The radical has to be identical before you can add or subtract them. Of course, that's different with multiplication. It's not a big deal. You can either multiply these together to get 600, or like I'm going to do here, I'm going to break them down. Now, because they're both underneath the same radical in the end, I can use the pairs from each of the two numbers to get my final answer. So I'm going to do 3 and 10 and 5 and 2. Here I'm going to do 2 and 10, and I know that breaks down into 5 and 2. So here's my first pair, and here's my second pair. So that leaves me with 5 times 2, which is 10. 10 squared roots of 6. I'm going to come over here and I'm going to do the exact same thing. I'll go ahead and break down my numbers individually. The 3 won't break down, but I'm going to write out my 11 D's plus the 7 more, giving me 18 D's. 1, 2, 3, 4, 5. That gives me 9 pairs. And then I'm going to break down my 48 and see what comes out of that. So we'll do 6 and 8, and 4 and 2, and remember that breaks down into 3 and 2. Now the reason this is so significant is right here I've got my pair of 3s, I've got a pair of 2s, and a second pair of 2s. So that's 2 times 2 times 3, which is 12. So then I get 12d to the 9th power. Over here, we're going to use distributive property. Doesn't matter that it is a radical. So that's going to be 2 root 6 minus 3 root 36, because 6 times 6 is 36. So then I'm going to simplify this and multiply them together, and I get 2 root 6 minus 18. Same thing occurs here, and that's going to be 2 root 15 minus 3 root 12. And the only thing you would have to do here is try to break these down to see if they could simplify, and if they can simplify, you would. So this breaks down into 4 and 3, and that's 2, so 2 times 3 is 6. So 2 root 15 minus 6 root 3 is your simplified result. Remember, you can only combine these together if the 15 and the 3, the numbers inside the radical, are identical to each other. Now, it doesn't change when you have a different index. It only changes when you're trying to mix indexes. That makes it a little bit messy. So I don't think we're going to throw you that curveball just yet. So that's going to give you the cubic root of 8 minus 2 cubic roots of 64. So that's going to be 2 minus 2 times 4, which is 8. So the answer to this problem is -6. Alright, our number 6, we're going to distribute this in. Square root of the cubic root of a of 2 a to the third plus the cubic root of 16a to the third. Break this one down by taking out your a, and you get a times the cubic root of 2 plus 2a times the cubic root of 2. Now your radicands are identical, so you have like terms. 1 plus 2 is 3. 3a times the cubic root of 2. Number 7, 8, and 9 incorporate multiplying binomials together, so we'll simply use FOIL or double distribution, whichever you're more familiar with. That's going to be 6 plus 3 root 5 minus 2 root 5 minus 5. That's the square root of 5 squared. Combine your like terms, and that's going to give you 1 plus root 5. Again, we get 4 times 3 minus 8 root 3 plus 5 root 3 minus 10. So combining your like terms, that's 12 and 10, so that's 2 minus 3 root 3. Number 9, use your perfect square trinomial shortcut, and you get 3 minus 2 times the square root of 15 plus 5. Combine your like terms, 8 minus 2 square roots of 15. Alright, in numbers 10 through 13, pay attention to actually what's happening here so that you understand how to properly rationalize the denominator. In 10 and 11 we're already familiar with it, but in 12 and 13 the rules change slightly, and so we have to really understand why we're doing this. Remember, rationalizing the denominator means we're going to remove the radical from the denominator of the fraction. What that takes is a perfect square. Over here on number 12 it's going to take a perfect cube, and then we need this perfect quartic is what we need over there. So we're going to multiply this by the square root of 3 over the square root of 3, just like we're familiar with. That gives you 2 square roots of 3 over 3. Again, root 6 over root 6, and that's going to give you root 60 divided by 6. And then we'll simplify that down into 2 square roots of 15 over 6, which is square root of 15 over 3. Alright, now remember, it took a perfect square to get the radical out of the denominator. This time it's going to take a perfect cube. So I'm going to need 3 of them in total on the bottom. So it looks like this. However, to make it more simple, you could rewrite it as the cube root of 5 times 5, which is 25. At that point we multiply these together and we get the cubic root of 200 divided by 5. Simplify that down to 2 cubic roots of 25 divided by 5. So how many of these will we need? We will need a total of 4. So that's the 4th root of 2 times the 4th root of 2 times the 4th root of 2. Remember to make it simple on yourself. Multiply that by the 4th root of 8. So what we get here is going to be the 4th root of 24 divided by 2. 24 doesn't break down because I never grab 4 of any single number out of 24, so I'm finished. From here till the end of the work, we're going to focus on conjugates. So please remember that the conjugates involve one of the values staying the same and the other switching to negative. Notice it doesn't always have to be your radical. However, if you want to be consistent every time, it can be. So I'm going to multiply the bottom and the top by the conjugate by switching one to the other. Now remember, the conjugate is the way that we introduce the difference of squares. Remember, the difference of squares eliminates the middle term, which is where the radical would show up if we tried to just multiply it together without using the conjugate. So now we get 1 minus the square root of 5 on top, and the difference of squares says it's a squared minus b squared. So that's going to be 1 minus 5, which is 4. One minus the square root of 5 over negative 4, which can be changed to negative 1 plus the square root of 5 over 4 if you wish. Right here you can either multiply by the conjugate, which is negative root 5 minus 2, or square root of 5 plus 2. You just have to switch one of them to get your difference of two squares. This time you'll have to distribute this through there, and you're going to get 3 square roots of 5 plus 6 divided by negative 1. Oh, sorry, positive 1, because that's going to be 5 minus 4, and you get your answer that way. Alright, number 16, 17, 18, and 19. They're just getting more complex as we move along, so just pay attention to how it works. Make sure that you've got your process down properly. 4 minus the square root of 2 over 4 minus the square root of 2. Then we're going to multiply the root 10 throughout, so we're going to get 4 root 10 minus root 20 divided by 16 minus 2, which is 14. You can simplify 20 into 10 and 2 and 2 and 5. 4 root 10 minus 2 root 5 divided by 14. In this case, we have a common factor of 2 in all of those whole numbers. So that's going to be 2 root 10 minus root 5 over 7. Remember, these two numbers must be identical in order for them to be simplified, so we leave it as that. Again, we're going to talk about this as the conjugate, so root 5 plus root 6 over root 5 plus root 6. I'm going to distribute 3 root 2 to both values, which gives me 3 root 10 plus 3 root 12 divided by the difference of squares is 5 minus 6, which is negative 1. That means that I can move this negative up here, and I get negative 3 root 10 plus 3, that's going to break down into 4 and 3 and 2 and 2, so that's going to be 6 root 2. Sorry, excuse me. No, that's right. Root 3, not root 2. And that's as simple as we can get it, unless you wanted to distribute the negative to both of your values. Number 18, again, we'll deal with the conjugate. 3 plus the square root of 5 divided by 3 plus the square root of 5. You can see that the algebra is just getting more complicated as we go along. Now I've got two binomials that we're going to use FOIL or distribution to, and we're going to get 12 plus 4 root 5 plus 3 root 5 plus 5 divided by 9, 3 squared, minus the square root of 5 squared, which is 5. And now combining like terms, the 12 and the 5 gives me 17. That's 7 root 5, and that's going to be a 4. Cannot simplify because there is not a common factor between the three whole numbers, so we're going to leave it like that. Alright, So we want to deal with this very carefully. The first thing you want to look at is rationalizing this denominator right here. Okay? And in rationalizing this denominator right here, I'm going to multiply the top and the bottom of this fraction by root 3. We're not dealing with the whole fraction, we're just dealing with the small fraction in the denominator. So that gives me 4 minus 2 divided by root 3 over 3 minus root 3 over 3. Next thing I'm going to do is find a common denominator among these two values. So that's going to be 4 minus 2 divided by root 3 over 9 minus root 3 over 3. So remember, this is a 1. Multiply both the top and the bottom by 3. Let's do the same thing to the top. We're going to rationalize this denominator across the top as well. And now I've got 4 minus 2 root 3 over 3. I will get a common denominator and multiply that by 3 over 3, giving me 12. So now, on the numerators, 12 minus 2 root 3 over 3 divided by 9 minus root 3 over 3. Now what we're going to do is use keep, change, flip by writing this as a traditional division sentence rather than a fraction over a fraction. So we're going to have this divided by the denominator, 9 minus root 3 over 3. Keep the first fraction the same, flip, change this to multiplication, flip the second fraction, 12 minus 2, square root of 3 over 3, times 3 over 9 minus the square root of 3. Now I can put these together as a single fraction, and I get 12 minus 2 square root of 3 over 9 minus the square root of 3. Now we're back to that old conjugate, 9 plus the square root of 3 over 9 plus the square root of 3. And we can multiply this in, which gives me 108 plus 12 square roots of 3 minus 18 square roots of 3 minus 6, because you've got 2 times 3 times 3, or the square root of 3 times the square root of 3. And then the denominator is going to be a minus b, so that's going to be 9 minus 3. Oh, sorry. 81 minus 3. There we go. All right, combine your like terms and you get 108 minus 6, which is going to be 102, minus 6 times the square root of 3 divided by 78. Our common factor in these three terms is going to reduce this to 51 minus 3 square roots of 3 over 39. Whew. That one was fun. All right, let's go on to an easy one, such as number 20. All right, so the first thing you want to do is recognize this as a rational exponent, and you're going to want to switch it into its radical form. So once you do that, it becomes a very simple problem. The square root of y minus 2. We go back to our conjugate, so that's going to be y plus the square root of y plus 2, and the square root of y plus 2. So then what I'll do is I'll distribute this in to that, and we will get y times the square root of y plus 2y divided by y minus. There's no common factor between any of those, so I am left for simplest terms. And now we are finished.